Welcome to my channel. Please subscribe and click the like button. In this video, I'll discuss how to select a split unit. While it may seem straightforward, by the end of this video, you'll understand the many factors to consider before making your choice. This video focuses on small split units. I'll create a separate video for VRF system selection. Be sure to check out my other videos on HVAC systems too. I hold the position of Senior Sales Engineer at a Mitsubishi HVAC distributorship, where I regularly receive inquiries from engineers and contractors seeking guidance on selecting the appropriate split unit for various applications. Although many of these requests seem similar on the surface, each situation presents unique considerations. To illustrate the complexity of this task, let's examine a few sample requests. By the end of the presentation, you'll understand why it's imperative to gather extensive information before making equipment selections. Let's embark on this enlightening journey together. I'll be covering several factors you should consider, although they won't be presented in any specific order. Once you're familiar with these factors, feel free to reach out to me or send an email to select the best possible system. Let's delve into these factors in detail. These are the topics I'm going to discuss. 1. Capacity. 2. Application and operating conditions. 3. Power. 4. Type of the system. 5. Single of multi-zone system. 6. Pipe lengths and location of the outdoor unit. 7. Indoor units and connection ratio. 8. Type of indoor units. 9. Budget. 10. Availability. 1. Capacity. Capacity can be a complex topic, so I'll simplify it. In any building, heat is gained during the summer and lost during the winter. Calculation of heat gain and heat loss in a building is very daily and very complicated process. There are software available to handle these calculations, taking into account factors such as the building's location, orientation, floor area, roof area, window area, number of occupants, equipment in the room, R-values of materials, and more. This software determines the worst-case scenarios for heat loss and heat gain. Software will give you what is the total heat loss and heat gain into different days in winter and summer respectively. After completing the load calculation, you'll have the heating and cooling loads as shown on the slide. However, keep in mind that this represents the worst-case scenario. When selecting a heating or cooling unit, it should be capable of handling the area's needs on these worst-case days. One drawback of heat pumps is that they lose capacity as the temperature drops. I hope you have watched my video on what is split unit. Therefore, ensure your split system has sufficient capacity for the worst-case scenario. You can simply request the performance data for each split unit and check if it provides enough capacity at those temperatures. If it's equipment cooling application, you should have the breakdown for sensible heat and latent heat load. You have to check your equipment can handle the sensible load. 2. Application and operating conditions. There are many split units available in the market, each with its own set of parameters. Based on operating conditions, I have categorized systems into 4 groups. Please note that this is my categorization to make it easier to understand. Type 1. Standard split unit, a summertime cooling shoulder season heating. Type 2. Low ambient heating unit, a summertime cooling and low ambient heating operation. Type 3. Low ambient cooling only unit. Type 4. Low ambient cooling with heating. Type 1. Standard split unit, a summertime cooling and shoulder season heating. In this situation, you don't need low ambient cooling or heating. You will require cooling in the summer and heating in the spring and fall. You might have a separate system for winter heating. Type 2. Low ambient heating unit, summertime cooling and wintertime heating operation. For this type of system, you need a special condenser unit that can operate effectively during winter. A standard unit won't suffice. Mitsubishi offers a hyperheat system that performs well in winter, maintaining a higher partial capacity. Heat pumps work by absorbing heat from the outside air and transferring it indoors. As the temperature drops, their capacity decreases. However, hyperheat units retain a higher partial capacity. For comparison, standard heat pump units typically have 40 to 45% of the rated capacity at minus 20 degrees centigrade, while hyperheat units maintain 75 to 80% capacity at minus 25 degrees centigrade. In both cases, it's strongly recommended to have a backup heating source. Type 3. Low ambient cooling only unit. Some applications, such as electrical rooms and server rooms, generate a lot of heat and require cooling even during winter. I created a separate video on the topic of comfort cooling versus equipment cooling, which you can watch for a full explanation. In these cases, we typically use cooling-only units. Other examples where winter cooling is needed include garbage rooms, mechanical rooms, and elevator machine rooms. This unit's rated for minus 40 degrees centigrade, and windscreens and stand for outdoor unit is a must. Type 4. Low ambient cooling with heating. This system requires a low ambient cooling unit, as described above. However, in addition to winter cooling, the application also requires heating. This creates a complex situation because the same unit needs to function in both heating and cooling modes during winter. For low ambient cooling, the condenser fan must run very slowly, while for heating, it should run at a high speed to absorb as much heat as possible. In this scenario, the operating range may be reduced. If cooling is priority, you can select low ambient cooling unit with heating. If heating is priority, you can select hyperheat unit that can work up to minus 25 degrees centigrade in heating and cooling up to minus 18 degrees centigrade or 10 degrees centigrade based on the unit. Different units have different operating ranges, so you need to select a split unit that meets your specific application requirements. There are many variations available, and it's important to choose the one that best suits your needs. Otherwise, you could end up spending extra money unnecessarily. Now that you're familiar with the 4 types of applications, let's explore the operating range required for the outdoor unit for each type of application. Type 1. Standard split unit, summertime cooling, and shoulder season heating. Typically, for this type of application, you can choose either a standard cooling-only unit or a heat pump unit. The operating range for cooling is around 14 degrees Fahrenheit minus 10 degrees Celsius, while heating may not go very low, possibly around minus 15 degrees Celsius to minus 20 degrees Celsius. A hyperheat unit is not necessary in this case, as these units do not offer higher partial capacity in heating mode. Type 2. Low ambient heating unit, summertime cooling and wintertime heating operation. For this type of application, you need a unit that can operate efficiently in heating mode under extremely low conditions. A hyperheat unit can function at temperatures as low as minus 25 degrees Celsius, maintaining about 80% of its capacity. In VRF systems, hyperheat units can perform even at temperatures as low as minus 30 degrees Celsius. Type 3. Low ambient cooling only unit. If you're using a 1 indoor, 1 outdoor setup, P-Series cooling-only units can operate in temperatures as low as minus 40 degrees Celsius, but it requires special hardware and software to operate in low ambient conditions. I've explained this in another video, so please check that for more details. You'll also need windscreens, along with specialized hardware and software. Keep in mind that a 208-volt 3-phase unit won't work down to minus 40 degrees Celsius, but with a low ambient hood and windscreens, these units can function at temperatures as low as minus 30 degrees Celsius. Type 4. Low ambient cooling with heating. This is similar to the previous type, but these units are also capable of heating. The typical cooling operating range can be between minus 18 degrees Celsius, while the heating operation range can go as low as minus 25 degrees Celsius. This is a complex situation and need to address case by case. Now that you have a better understanding of the different types of applications and the operating ranges available for split units, you can use this knowledge to select the right unit for your specific needs. Let's explore some applications and determine which units are best suited for them. Imagine you need a split unit for cooling during the summer in a house or office, where heating isn't necessary because you already have a heating system. If your cooling capacity requirement is under 3 tons, you can opt for a cooling-only unit. However, for multi-zone systems or capacities above 3 tons, you'll need a heat pump. Keep in mind, though, that heat pump heating is best suited for shoulder seasons like fall and spring. The second application I'd like to discuss involves the same residential or office setting, but with no other heat source available. In this case, you'll need a heat pump to provide primary heating throughout the winter. However, one key challenge with heat pumps is that they lose capacity as outdoor temperatures drop. Therefore, it's crucial to choose a heat pump that performs well in colder conditions. Mitsubishi's Hyper heat pumps retain 70 to 80% of their capacity at -25 degrees Celsius. However, it's highly recommended to have a backup heating system. As mentioned earlier, you'll need a Type 2 heat pump unit for this application. The third application I'd like to discuss is for cooling equipment or computer rooms. In this case, you need a unit that operates both in summer and winter. When running in winter, special controls are necessary. I've discussed this in detail in a previous video, which you can watch for more information. As mentioned earlier, you will need a Type 3 unit. The next application is similar equipment or computer rooms, but you only need cooling during summer. In this case, you can go with a standard cooling-only unit. As I mentioned earlier, this is a Type 1 indoor unit, and windscreens or low ambient controls are not required. Next, let's discuss an application where you need cooling during summer and heating during winter for equipment or computer rooms. In this scenario, you'll need a unit that provides both heating and cooling. The unit will require windscreens, low ambient cooling controls, and heating capabilities, which is a Type 4 system. The next application is a garbage room. For this type of space, a Type 3 unit is required, that is low ambient cooling unit, as cooling is needed even during winter to reduce odors. Another example is a wine cellar, where the temperature must be maintained at around 50 degrees Celsius. This type of application requires a special unit since standard split systems cannot achieve the necessary indoor temperature and humidity levels. Now, let's talk about power requirements. Split units are not available in every voltage, and different capacities require different power supplies. You'll need to choose based on what's available at the site. Let's dive into the details. In your home, you typically have 120 volts single-phase or 240 volts single-phase power. In commercial buildings, the options include 115 volts single-phase, 208 to 230 volts single-phase, 208 to 230 volts three-phase, or 575 volts three-phase. In some buildings, 460 volts three-phase is also available. Now, let's look at the power requirements for split units. Small units under 5 tons are available in 208 and 230 volts single-phase. One feature to note is that these units can handle up to a 10% voltage fluctuation, reaching 253 volts. This means any unit up to 5 tons can be used in residential applications. Only a few models are available in 115 or 120 volts single-phase. That is 9 MBH and 12 MBH. Units 6 tons and above are available in 208 to 230 volts three-phase or 575 volts three-phase. These systems require separate power supplies for the indoor units, which typically run on 208 to 230 volts single-phase. This is especially true for VRF systems, although other systems can have the indoor unit powered by the outdoor unit. In summary, for residential applications, 2 units are available with 120 volts single-phase power 9 MBH and 12 MBH. Other units, up to 5 tons, require 240 volts single-phase power. For commercial applications, up to 5 tons follow the same power requirements, while units 6 tons and above use 208 to 230 volts or 575 volts three-phase, though 460-volt units are in common. Now, let's discuss system types. In this presentation, I focused on air-cooled split units, but when designing a system, you should be aware of the various options available and choose the best one for your application. 1. Air-cooled split systems or VRF systems. The condenser is installed outdoors and cooled by air circulation. 2. Water-cooled condenser systems. Similar to air-cooled systems, but the condenser dissipates heat using a water system. 3. Total hydronic systems. These generate hot or cool water, which is circulated to indoor units. A chiller is used for cooling, and a boiler is used for heating. 4. Another version of hydronic systems. These feature water-cooled condensers that can generate hot or cool water, reducing the need for fossil fuels. 5. Gas-fueled systems. These are popular due to their low cost but provide less comfort compared to VRF or split systems. Natural gas is used for heating, while a condenser is needed for cooling. 6. Packaged systems. In these systems, the evaporator and condenser are combined into one unit, often installed outdoors. A common example is a barred unit, which is mounted on the exterior of a building. 7. Water-cooled packaged systems. Similar to packaged systems, but the condenser is water-cooled, eliminating the need for ductwork to the outside. As a designer or engineer, you should be familiar with these systems in detail, though I've only provided a brief overview here. Next, we'll cover single one-on-one systems versus multi-head systems. A split unit can either be a one-on-one system, one outdoor unit with one indoor unit, or a multi-head system, one outdoor unit with multiple indoor units. One-on-one systems can be cooling-only units, but multi-head systems are only available as heat pump units. For multi-head systems under 5 tons, you can operate either in cooling or heating mode, but not both simultaneously. For units 6 tons and above, VRF systems offer the capability to cool and heat different zones simultaneously, which I'll cover in another video. Pipe lengths and the outdoor unit location are important considerations when selecting a split unit. Unlike hydronic systems, where water is pumped through the pipes, split units use refrigerant, which is driven by the compressor and has specific pipe length limitations. First, determine the location of the outdoor unit, then plan the piping route and calculate the total length. Ensure that the unit you select can handle this length. If the length exceeds the system's capability, consider upgrading to a VRF system, which can support longer pipe runs. Next topic I want to discuss: indoor unit connection ratio. When multiple indoor units are connected to one outdoor unit, they may not all run at full capacity. In this case, you can connect more indoor units than the outdoor unit's capacity. For Mitsubishi units, the total sum of the indoor unit's capacity should be less than 130% of the outdoor unit's capacity. This also applies to VRF systems, except for heat recovery systems, where the limit is 150%. If indoor units are connected up to 130%, and they all demand full capacity, their output will be prorated based on their rated capacity. Depending on your application, you may want to connect units at 100% or 130%. Another important decision is the type of indoor unit you'll use for each zone. You can mix and match different types of indoor units, and each type has a different capacity range depending on the series. Let's take a look at the indoor unit options available. As mentioned earlier, there are different series for different applications. Here are the types of indoor units available for the M series, each with a corresponding capacity range. For example, wall-mounted units have a minimum capacity of 6 MBH, while all other types have a minimum of 9 MBH, except for multi-position air handlers. For low ambient cooling and heating applications, we typically use P-series units. All of these units have a minimum capacity of 12 MBH, except for case coils, which are used with third-party air handlers and have a minimum capacity of 24 MBH. For VRF systems, there is a wide range of indoor units with varying minimum and maximum capacities, as listed on the next slide. Here, you'll find the minimum and maximum capacities for each type of indoor unit. Ceiling cassettes are available in both 3 feet by 3 feet and 2 feet by 2 feet sizes. There is also a one-way cassette option. Ducted units come in low, medium, and high static versions, and floor-mounted units are available in both exposed and concealed styles. You can choose the right indoor unit based on your specific needs. When do a video on VRF systems, I will go into more details. When selecting a split unit, it's crucial to understand your project budget. You can design a sophisticated system with many features, but if the budget doesn't allow, you may need to choose a simpler system. At the beginning of a project, it's important to have a clear understanding of both the project requirements and budget to select the right system. Due to ongoing supply chain issues and many other factors, suppliers are facing delays in unit availability. It's important to be aware of when your units will be installed and ensure they will be available by that time. If delivery times are long, consider ordering your units in advance. We've covered many factors to consider when selecting a split unit. In summary, know the heat gain and heat loss for your application. Determine whether you need a standard heat pump or a low ambient cooling unit or low ambient heating unit. Check the power availability at your site and the power requirements for the unit. Decide on the type of system. In this presentation, we focused on air source heat pump units only. Determine if you need single one-on-one system or multi-head unit. Decide no of indoor units, capacity and type of each indoor unit. Check pipe lengths are within the permissible lengths. Check equipment and installation cost is within the budget. Check the unit availability. In just 20 minutes, I've covered several important factors to consider when choosing a split unit. However, there's much more to know beyond what we've discussed here. I'll be diving deeper into each specific series, breaking down their features and benefits in more detail in future videos. So, stay tuned for those if you're looking for more comprehensive information. Thanks again for watching, and I look forward to sharing more insights with you soon.